Okay, I'm hopeful I gave you enough time. Did I give you enough time? Hopefully, kind of, maybe, yes-ish. Breakout room number 3 is still working because they're not back yet. Okay. Who are my people who are sharing? Who are my sharing people? Who are my people who are sharing? Did you pick someone in your room to share? Or is this a failure? Who are my people who are sharing? Mandy. Who else? Somebody who wasn't in Mandy's room. I can put you, Daniel, all right? And somebody who was not with Mandy and Daniel. You know the person to share. This is not hard, people. Here we go. Somebody else. Somebody among Ashley, P, Elijah, Sarah, or Laura. Who's gonna share? Sarah's unmuted. Thank you for volunteering. Okay, here we go. So first share. Mandy, you volunteered first. You get to go first. What's my first share? 1 comma.
1 comma 1,494.
11494. Awesome. Daniel, second. 2 comma.
1942.
1942. Awesome. Sarah, 3 comma.
2578.
Spectacular. 2578. Sarah, go again. 4 comma.
3402.
3402. Awesome. Daniel, 5 comma.
4414.
4414. Spectacular. Mandy, last. 6 comma.
5614.
5614. Okay, notice that none of those overflowed with P, right? P is 1, 2, 3, 4, 7. None of those overflowed with P, so I don't have to worry about that. We're good. We can generate shares. Yes, we are happy. We can generate shares. We're good. All right, let's go to the other side of things then. I'm going to totally erase this slide. Jason, question first.
I'm kind of lost right now. I don't know how they got those numbers.
1, 2, 3, 4, 5, 6, or the second parts?
The second parts.
So you're just plugging your x's into the polynomial. So 14 or 1942 is equal to 94 times 2 squared plus 166 times 2 plus 1234.
Okay.
Just plugging in.
Thank you.
Yep. And remember, the 1, 2, 3, 4, 5, 6 are totally arbitrary. That's what the Shamir threshold scheme has you use, but you can use pretty much anything you want. We're just arbitrarily using those. All right, let's flip to the other side. You don't know anything that was on the previous slide. Well, you know P, which again doesn't matter in this case. We don't have any overflow, but that's okay. So we know P, that's it. That's all we know. And we are going to say that people number, Bob number 2, number 4, and number 5 want to reconstruct. So Bob's number 2, 4, 5 want to reconstruct. You have no knowledge of anything on the previous slide other than these 3 shares, because these Bobs are coming together. So we've got 2, 1942. We've got 4, 3402. And we've got 5, 4414. That is all the information that we have at this point in time. No cheating, no looking back to the previous slide. This is what we have, and we want to reconstruct. So we need to make some Lagrange interpolation polynomials. In this case, we're going to have notation changes it a little bit. L sub 2 of x, and j is going to be 4 and 5 in this case, right? It's not sequentially ordered with 1, 2, and 3. I have 2, 4, and 5. So we've got L sub 2 of x, and that's where I want my j to be 4 and 5. So this is going to be x minus x sub 4 over x sub 2 minus x sub 4 times x minus x sub 5 over x sub 2 minus x sub 5. Everybody good on why I don't have j equals 1, 2, 3 like I did before? My shares are 2, 4, and 5. So that is what I'm going to have in this case, 2, 4, and 5. The x's with subscripts are the first part of the shares. So this is going to be x minus 4 over 2 minus 4 times x minus 5 over 2 minus 5. It's the first part of the share. X is still a variable. I'm trying to make a polynomial, so X stays as a variable, but everything else gets plugged in with the first part of the share. So I can simplify this. I'm gonna have a -1/2 and a -1/3. So my fraction is gonna be 1/6, and then we can say x squared minus 9x plus 20. I could FOIL out distribute that 1/6 if I wanted to. I could also remember technically what this means is 6 inverse mod p, right? I'm dividing, so technically that's 6 inverse mod p. We're gonna save all our inverses until the end, and if we don't have fractions, then we won't need to use them. But you could use Perry if you wanted to and get each of those. Okay, give me a thumbs up that we see where L sub 2 of x is coming from. Yes, we're good, we got it? Okay, go ahead, I'm gonna write, you guys can do it on your own, do L sub 4 of x and L sub 5 of x for me, please. Do both of those, L sub 4 of x and L sub 5 of x. Okay, some people's heads are still down, they're still writing. Some people are looking back up, so I'm going to assume that you're done. L4 of x should be -1/2 x squared minus 7x plus 10. And L5 of x should be 1/3 x squared minus 6x plus 8. For the 14th time today, give me a thumbs up on those. We understand those, we are good, yes. Okay, I'm going to skip back 2 slides because this information we don't know. Here, this is my polynomial that I am looking to create. So I need to take each of those Lagrange interpolation polynomials and multiply them by the second half of the share. That's what's going on to recreate my polynomial p of x. Each of these Lagrange interpolation polynomials multiplied by the second half of the share. So that is going to give me, here's my polynomial. Go up over here, I think I can fit it all. My polynomial to reconstruct, p of x is the second half of the share is 1942 times 1/6 times x squared plus 9x plus 20. That's my first piece. I'm gonna have 2 more pieces. Second half of the share times your first Lagrange interpolation polynomial. Second half of the share times your first Lagrange interpolation polynomial. Plus, next one, 3402 times, ooh, that did not work. 3402 times -1/2 times x squared minus 7x plus 10. 3402 times negative 1/2 times x squared plus 7x plus 10 plus, sorry, we'll do a new line here, 4414 times 1/3 times x squared minus 6x plus 8. 4414 times 1/3 times x squared minus 6x plus 8. Good? Clear? Okay, last thing here. We wanted to reconstruct the secret. We wanted to come up with k. So k is equal to p of 0, right? That's what you get out when you plug in 0. All my x's are going to go away when I plug in 0. So this ends up being 1942 times 1/6 times, inside my parentheses, the 20 is the only thing that's left. Everything else goes away. The x squared goes away, the minus 9x goes away. Plus 3402 times negative 1/2 times 10. The x squared goes away, the 7x goes away. I am plugging in 0. Plus 4414 times 1/3 times 8. 4413 times 1/3 times 8. In this case, if you multiply this out, all of the fractions are actually going to go away. So this ends up actually equaling, if you do it on your calculator, 1234. That's great. That's spectacular. That is our secret. That is what we were supposed to get. If you would have gotten, so if we would have done another example here, and we would have gotten p of 0 equals, I don't know, 1542 over 841, something like that. If we would have gotten a fraction for an answer, then we would have said 1542 times 841 inverse mod p. So you can save all your fractions until the very, 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 very end. You don't have to deal with them in the meantime. You can totally deal with your fractions at the absolute end of all of this and just do 1 inverse mod p. If you want to, you can deal with them along the way if you don't like having fractions, or you can save them all the way until the end and then deal with them. So when I said we have to deal with inverses mod p, that's true, but it's not really as bad as I made it sound. So you can save them all the way until the end and then figure out your k value. Okie dokie. That was a lot today. How are we doing? Yes, no, yes, thumbs up, yes. Okay, there are some on your homework where you both have to generate shares and you have to reproduce a key based on a certain number of shares. So we've got both of these that we are going with. Perry is going to be your friend in this case, and just be careful of mod p. We had no overflow in this example because I wanted to try to concentrate a little bit more on the math, but be careful of mod p when you are doing your homework. All good? Yes. We'll see if it's all good when you try your homework, but all good at least for now, hopefully. Elijah, question.
Yeah, I actually had a homework question.
Okay.
So for the rotation of bits, is that, I don't know if it wasn't in the slides. Is it around, like, is it rotations around 32 bits?
Yes.
Like what point are we rotating around?
So that's where you shift stuff to the left and it falls off and goes back to the beginning.
Right, but what's the limit for looping around?
I think you're treating things as 32 bits. Let me look on that for sure and I'll come back with an answer.
That's what I assumed, but I guess I just wanted to ask and see if you knew.
I think so. I think that's what you want to do. Yes.
Yeah, because everything else in the protocol is 32 bits. So.
Yeah, I would think it is then. Yeah.
Okay.
Okay. Anything else? Other questions? Okay. Monday, then, what we are doing, totally appropriate to life right now, is poker over the phone. So that's what we're doing on Monday. It's just kind of a fun way to finish up the semester and see how we can do poker over the phone. And then Wednesday, we are going to talk about how you can cheat at poker over the phone. So that is Monday and Wednesday. That is the last 2 things for the semester. There is poker over the phone on the homework as well. So you're going to need to do a couple of those. But that's the plan for the last 2 new class periods. Going once, going twice. Anything else before we sign off for the weekend? Okay. Thank you for coming to class on Friday. I appreciate it. I will see you guys on Monday. Have a good weekend. Bye.